Alright, now the disk method for a solid of revolution. The idea behind this whole thing is, where are my sticks? Oh, this will work perfect. The idea is this. If we get a representative rectangle like this, and we're able to, well, maybe it's not working out that great, but we're able to rotate it like this, it creates a circle. But better yet, it creates something that looks like this. It almost creates it perfectly. If we were right smack dab in the middle, it would create this, which we call this a disc. This is disc shaped, so it's a cylinder for all intents and purposes. So what we have is you're going to get a representative angle that looks like this. And this length is going to be, we're going to call this R. And even better yet, we're going to call it R of x. And this is your width. And usually the width ends up being a dx. Just go straight to there. It ends up being a dx. Now, when we rotate this, what's going to happen is you're going to get, well, here's your axis of rotation that goes around it. But here, is your rectangle, the top of which is going to end up being an f of x. So most of the time, there's going to be two different ways that we do this. You're either, this length is always going to end up being like an f of x, or maybe like g of y or something like that. But your job, whenever we have this disk method, is we got to come up with, how do we figure out the volume of this disk? Because now what we're going to get is a bunch of disks of different sizes that we're going to add up from one bound to another. So how do you figure out the volume of the disk? Which you can think of as a cylinder. Well, if we're right here with this, that R represents a radius. So how do you calculate? We want the area of the circle. How do you calculate the area of the circle? Pi r squared. So this is going to be pi times r squared times the height, which in this case is a width. Or we call it the width, whatever it is. Now, in order to calculate the volume of the solid, the entire thing, we have to add up all the disks. That's the sum of all disks. So how do we sum up the disks? We're going to integrate. I'm going to bring the pi out because pi is a constant, so you can bring that in front. And we're going to go from A to B. Whatever the problem says, all right, this is what we're going to have to do. We're going to get r squared of x dx. There's your height. The dx talks about the width. Because remember, what we're actually going to do is we're going to shrink that width down to make it infinitely small. So it becomes that differential dx. Now, we're going to use this if it's a horizontal line of rotation. So if you have a horizontal line like this, and we're going to rotate around that line, and we create the rectangle that does this, we're going to use just a regular one like this. Now if it's vertical, the volume is going to be no different. Thanks. It's just going to be r squared of y dy. So it's just going to be, if I'm here and I'm rotating around a vertical line, I'm going to get a disk that goes like this. Like this disk ends up like that. And either way is fine. It really doesn't matter. All right, now this is if you're on the x or y axis. If you're off the axes, for example, if here's your axes, here's your line of rotation, which say is y equals 2, and you have let's say that's r of x. Now if I draw my rectangle here, we have to calculate two different distances and subtract them. We have to calculate this distance right here. What would be that big distance to get from the line from our x all the way up to the value of the function? What would that be? It would be r of x, because that would just be the value of the function. Now, for this case, what's this length right here? Yeah, that would be a 2. Or generally speaking, that would be a c. It could be any number. Now, how would I calculate this length of the representative rectangle at that point? Not half of r of x. How would that change based on the number 2 that we moved everything up to? What would I have to do to r of x? Add 2? It's one of those 4. Final answer? You sure about that? You'll end up subtracting 2. So our radius, we'll take whatever this function is, take the function, say, well, if that's f of x, we'll say this is f of x instead. And we're talking about a radius, because this ends up being the radius right here. R of x is the, that's f, sorry. r of x is going to be the length of the rectangle, since r, rectangle r. It's going to be f of x minus whatever number this is. In this case, it'd be 2. And then we'd take this, and we'd go into the whole from a to b of f of x minus 2 quantity squared dx. So if we're off the axes a little bit, we have to calculate the length of the actual rectangle itself. It's going to be the function minus the distance from the axis that we're going to be. So just keep that in mind when we're